So, hi there everyone. Today we shall see the fourth lab program of machine learning laboratory that is build an artificial neural network by implementing the backpropagation algorithm and test the same using appropriate data sets. So before going to our program or the algorithm, we need to know several neural network concepts that are important. So as I have listed here, the first thing is input. Fine. Input is nothing but the source data which is fed into the neural network with the goal of making a decision or a prediction about the data. So here the data is broken down into the binary signals which is allowed to be processed by the single neuron. Fine. Then the second thing comes here is the training set. The training set is nothing but it has a set of outputs for which a correct output is no. This can be used to train the neural network. Then the third one is the output. The output of neural network can be a real value that is between 0 to 1 or a boolean value or it may be a discrete value. Then comes the activation function. So in activation function, each neuron accepts the part of the input and passes it through the activation function. So the most commonly used activation function is sigmoid function. The sigmoid function will use in our program further. So these activation functions, what they do is they normalize the output to give a range to ensure the model has stable convergence or not. Fine. Then initialization of weights is done. Here, every neuron is given with a numeric weight. The weights are applied to the activation function to determine the output of the each neuron. Then comes the forward pass. Here, the forward pass tries out the model by taking the input, passing them through the network, and allowing each neuron to react to the function of the input and generate an output respectively. Then the last thing is gradient descent. The gradient descent is a mathematical technique that modifies the parameters of the functions to descend from higher value of the function to the lower value by looking at the derivatives with respect to each of its parameter. So applying the gradient descent to the error function, which will help to find the weights and achieve lower and lower error values so that it can make the model more and more accurate. So these are some basic concepts that we need to know before starting our backpropagation algorithm. Now let's see some stages of neural network learning. So these are the steps that are generalized for neural network learning. The neural network learning model training occurs in 6 stages. So the first stage is initialization. In initialization, what happens is we initialize the weights which are applied to all the neurons, and these weights are then taken at random. So we can take the weights randomly. Fine. Then in forward propagation, what happens is it is a second stage. The input from a training set is passed to the neural network and the output is computed here. Then in the third stage, the error function, uh, in the error function, it captures the delta value or the difference value between the current output and the actual output of the network. Then the fourth is the main thing that is backpropagation. Here the backpropagation has an objective. That objective is to change the weights of neuron in order to minimize the error function. So that's what we'll see in the algorithm now. Then weight update. Here weights are changed to an optimal value according to the results of backpropagation model. And then the last stage is iterate until convergence. As the weights are updated by a small step called learning rate, therefore several iterations are required in order for a network to learn. So these number of iterations needed to converge depends on the learning rate. So these are the six stages of neural network learning. Now let's discuss about the backpropagation algorithm. Here the backpropagation algorithm is spelled with some of the parameters like training example, eta. Eta is nothing but the learning rate, and n in is the total number of nodes, n out total number of output nodes, then n hidden are the total number of hidden nodes. Fine. Here, each training example is a pair of form x comma t, where x is a vector of network input value and t is a vector of target network output values. So eta is a learning rate, that is zero point 0.5. N in is the number of network inputs. N hidden is the number of units in the hidden layer, and N out is the number of output units. So the input from unit I into unit J is denoted as xji, and the weight from unit I to unit J is denoted as wji. So these are the some basic information to be known for the algorithm. The first step is that we should create a feed-forward network with n in inputs, n hidden units, then n out units. Okay, then we'll initialize all the weights to the small random numbers. Then, until the termination condition is met, for each x comma t in training examples, then the propagate input forward to the network takes place. So, input x is passed to the network and computes the output value of the every unit u in the network, then propagate the error backward through the network. Here, the output unit k calculates the error term by using this formula. Then in hidden layer, the unit h calculates the error by using this formula. Then in the fourth step, the weights are updated using the formula as WJI. It is an old weight. It is added to a new weight. New weight is calculated by using this formula. So we can see here it is a artificial neural network node. It is an input layer, fine, with input nodes, then hidden layer with hidden nodes, then output layer with output node. Here, training examples are given, that is sleep and study. Then the expected output, fine, in percentage. Then here normalized input is given. Fine. Let's see the program. First of all, here NumPy is imported. Fine. NumPy is imported as NP, that is a data frame, and also we have two inputs are for our network, that is sleep and study, as we have seen here, that is sleep and study. Fine. Sleep and study. In the second line, we can see x is equals to np dot array with the first instance, that is 2 comma 9. This is for 2 hours for sleeping, then 9 hours for studying. Similarly, second instance, then the third instance with the data type float. Fine. And the expected output is given here, that is 92%, 86%, and 89% with the data type float. In the third line, it is to normalize the data, and the y here, y is used uh, to convert the output data to the fraction values. Fine. This ANN program, that is artificial neural network program, uses the normalization. So it uses the normalization to change the value of the numeric columns in the dataset to common scale without distorting the difference in the range of the values. So hereby the normalization is a good technique to use when you do not know the distribution of your data, or when you know the distribution is not the quotient value. So the normalization is used in artificial neural networks. Then we'll use the sigmoid function. We know that sigmoid function is an activation function. We'll define the sigmoid function here using this formula. Then the derivative of sigmoid function is defined with this formula. Then in the next part of the code, we'll initialize the variables such as epoch for 5,000. Then LR is nothing but the learning rate. Fine. The epoch is nothing but we are going to set how many iterations are required for our program. Then learning rate is equal to zero point 0.1. It is kept as low as much possible because see we can see a zero point 0.1. Then we are going to create a neural network where a neural network consists of two neurons in input layer, that is see we can see here with input layer with two neurons. Then comes the hidden layer with three neurons. Then an output neuron with one node. Here neurons are nothing but nodes. In the next step, we'll initialize the weights and bias values. The weights are from input layer to the hidden layer and hidden layer to the output layer. Fine. So hence WH is nothing but the weights of the link from input node to the hidden node that are taken randomly. And BH is nothing but the bias value. Uh, it is a link from input node to the hidden node. Similarly, W out is nothing but the output link from the hidden layer to output layer. Then B is nothing but the bias value from output layer to the hidden layer. Fine. It is also taken randomly. Okay, then comes in we can see here a for loop epoch that is iterated for 5,000 times because we have initialized the epoch as 5,000. Fine. Then in forward propagation, h input 1 is equals to np dot of dot x comma wh, where we are using the dot function that is in the numpy module, which is used to perform the dot product. X is nothing but the input and it is multiplied with the weights. Then this result is added with the bias value. Fine. Then this is given to the sigmoid function of the neuron, which is in the hidden layer. Similarly, we perform the same thing for the neurons in the output layer. Fine. Then in back propagation, we'll identify the errors. So the errors are identified are the two layers that are the first thing is in the output layer, that is EO, using this Y output, then EH in the hidden layer. Then we'll check how much hidden layer weights contributed to the error. And also we are going to update the weights at the output layer and hidden layer by these lines in the code. And then we'll print the output. So let's see the program by executing it. So this is the code which I have used. Let's run it. Here we got the normalized inputs with some input values, then actual output, then predicted output. Predicted output is 0.82. The if you run again, you'll get some other value. The values will be changed. 8.5. Fine. So that's the backpropagation program. Thank you.